Hey everyone, Mr. Skelton here. We are back at it for lesson 5 in unit 11, and today we're going to be specifically talking about the correlation coefficient, another idea that falls within statistics. And so let's just jump right into it. Today I'm going to be asking you to use the graphing calculator to calculate the correlation coefficient, and that you'll be able to describe the correlation based on a graph. Now, just a forewarning, you can calculate the correlation coefficient by hand. However, I am not going to ask you to do that in this unit moving forward. So you will need a graphing calculator for this. There could be a way to do it on a scientific. I'm not sure how to do that yet. I haven't looked into it, but I know how to do it on the graphing calculator. So make sure you have yours handy. If you don't have yours handy, make sure you hit pause and go find it so that you can know how to do this. So let's talk about what correlation is. I'll show you some pictures here in a minute, but there are a lot of different ways, excuse the bell, there we go. There are a lot of different ways to calculate this correlation coefficient. There are different correlation coefficients. We're going to be using what's called the Pearson's R value, all right? So the correlation coefficient is most commonly referred to as the R value. When you do it in your graphing calculator, it will show up as R on your screen. So we're going to be using Pearson's R value. So what is it? Well, it's basically a relationship between two pieces of data. All right, it's when two sets of data are linked together, either strong or low, and we're only focusing on the linear part of it. There are no curves with this, so we're talking about data that's linear. Okay. Correlation, the word itself is made up of the word co, which means together, and then relation. So pretty basic stuff. We have a positive and negative correlation. A positive correlation is when the values increase together. So for example, the more hours you spend on the treadmill, so as your hours increase, the more calories you're going to burn. Those increase as well. Negative correlation is when one value decreases while the other increases. For example, as the chicken gets older, so as the age increases, the amount of eggs the chicken produces goes down. That would be an example of negative correlation. So what does it look like? On this next slide here, you can get an idea, and I tried to put this in color for you, but this is what it looks like graphically, and this is what you're going to be able to do on your graphing calculator. 1 is a perfect correlation. So basically we go from 1 to -1, and the positive, if you remember your slopes, right? The positive numbers have a positive slope. The negative numbers have a negative slope, and you can see that. All your positives are going up and to the right, up and to the right, up and to the right. Your positive correlation. As x is increasing, your y's are increasing. All right, and you can see that. Here's your negative numbers. Your negative slope, or a perfect correlation for -1, would be as your x values are increasing, your y values are decreasing. We talked about on that with the first slide. So there's what it looks like graphically, and you should know this. We have a perfect correlation, so 1 and -1 is a perfect positive correlation, which means there is a fixed, just a fixed proportion. Every time one increases, there's a fixed proportion as the other increases as well. Same, likewise with the negative, okay? And then we have high correlation, high negative correlation. We have a low positive correlation, a low negative correlation, and then when we just have things all over the place, there's no correlation. These numbers right here, 1, 0.9, 0.5, -0.5, -0.9, these are your R values, okay? These right here are your R values. Those are the correlation coefficients. We're basically trying to figure out how the two variables, what relationship they have together. Is it a really close relationship? Is it a near perfect relationship? Or is it something that's, you know, there's really no relationship at all? It's kind of just all over the place. Okay? And so that's what we're focusing on today. So let's just jump right into some examples. Shouldn't hopefully take us too long. You are going to need your graphing calculator, and if you want to hit pause to get that, you can. So let me slide this over. So here we got a situation where the local ice cream shop keeps track of how much ice cream they sell versus the temperature on that day, and here are the figures for the last 12 days. So let's grab our graphing calculator out. I may have to zoom out so that I can get every function on the screen for you. Try to get rid of the glare as well. So let's clear our memory. So second plus sign mem, and let's reset it. All right, and we're going to go to our stat button. When you hit stat, let's hit edit. Hit enter on edit. And we're going to fill the temperature in as list 1 and the ice cream on list 2. If you want to hit pause, you can. I'm going to do this very quickly and hopefully not screw it up. Okay, and then the second, your Y's are going to be your ice cream sales. 215. Make sure when you put in your list that you have an equal amount. It looks like I do. Again, hopefully you fast forwarded through that if you needed to. Okay, so there's our data. So what we want to do is we want to try to see this data on our graph. So we did this in first semester. You may not remember it, but that's okay. We're going to go through it again. We want to create a scatter plot, right? So here's what we want to do. We want to go to, let's see, where is it? We want to go to stat plot. So we want to hit second and then y equals. Right now our stat plots are turned off, so just hit enter, which will turn it on, hit on again, and we should be good. So when we hit graph, they should appear, but they don't. Why is that? Well, that's because our window is set to 10 right, 10 up, 10 down, 10 left, and look at our numbers. We got up to 17, up to 408. Now you can adjust your window, or I'll give you a shortcut here. Hit your zoom button, and you'll scroll down to zoom stat and just hit enter, and boom, there it is. Okay, so there's our scatter plot. It looks like we have a pretty good, if we're comparing here, a pretty high positive correlation. That looks, you know, again, we can estimate. We could say, that looks like 0.8, maybe 0.75. This is 0.9. This is 0.5, maybe somewhere in between, or maybe we think it's, 0.92. We can make some estimations based on our scatter plot, but we want to find the exact value, right? Okay, so if you wanted to put a line through there, we could. We don't have to. We just need the scatter plot, okay? So here's what we're going to do next. In order to do this, we need to turn on our diagnostics, which is new for you. You have not done this, so here's how it works. You'll see right above the number 0, it says catalog. So we're going to hit second 0. And we're going to scroll all the way down. This takes a while. You can just hold it down. It's in alphabetical order. So you're going to go down to D, and it should say diagnostics on. So we're just going to hit enter on that, diagnostics on, and hit enter again, and it says done, so it's on. Okay. Now what we're going to do is hit our stat button. So we hit stat, and now we're going to calculate, and we're going to go to linear regression line. So this is what we've done in the past, right? This is all linear data, correlation coefficient linear. So we're going to hit enter on that. And if you remember, this is where we have to go. Second L1, comma, second L2. Okay? And we can hit enter. And you'll see right down here at the bottom, our R value is 0.957. So our correlation coefficient, or our R value, is 0.957, which is a high positive correlation. So what does that mean? Well, that means there is a very, very strong correlation. As the temperature increases, the number of ice cream sales will also increase. There's a strong correlation between those two pieces of data, and that is correlation coefficient. Okay? We have one more on the back. If you want to go through that, we can. I'll go through it very quickly again, just to go through it all. So I'm going to clear my memory again one more time. And if you want to turn off the video, I'm not going to do anything different on this one than I did on the last one. So if you get it, great. If not, I'm going to go through it one more time with you. So I'm going to go to stat, edit, and I'm going to put in my list. So this is height and weight of 10 friends. Okay? All right, and then my weight in kilograms will be my L2, starting with 87, 55, 52, 94, 87. And again, I always double check, make sure I have it lined up, and I do. Okay. We want to look at this data, right? We want to take a look at it and make a scatter plot. So we're going to go to second stat plot. We're going to make sure we turn that on. And we're going to hit graph. Nothing will show up. So hit zoom. Go down to zoom stat. Zoom stat, hit enter. And there you go. So not looking so closely related to one another, right? It looks kind of like a low positive. Looks still positive, right? It's still trending. It's still trending right through there, but you have some, looks like you have some outliers, some numbers that maybe don't really fit, kind of spread out, so it looks like more of a low positive, still positive, correlation. So let's figure out what that, now this question just says, what is it? I would say definitely B, but I'm going to go ahead and actually find the correlation coefficient with you. So remember, we have to turn on our diagnostics for this, so we're going to go to second catalog, go all the way down to diagnostics. There's diagnostics, hit on, hit enter again, so it says done underneath it. Go to stat, over to calculate, linear regression. What do we want to take the linear regression of? L1, comma, L2. Hit enter, and you can see we have a 0.672 correlation coefficient. So not very strong. Still a correlation there, right? If you look at, we'll go back to the first, we flip it over. We're in between low and high, but 0.6 more closely related to the low positive correlation than to the 0.9, okay? And again, if you wanted to actually find like the slope, actually it has the slope listed here. If you wanted to, like when you graph this, there's no linear regression line. If you actually wanted to see the line on that, remember you can just go to stat, calculate linear regression line. If you wanted to get the full equation, and make predictions and things like that, you would go second L1, comma, second L2. You'd hit vars, y vars, function, enter, enter. And when you hit graph here, you would get the line that actually goes through it, okay? And so we could go to like second table, right? And we could make predictions, like we said, okay, if the person weighed 250 pounds, well, we wouldn't want to scroll down all the way to 250, right? We would want to go to, where's our table setting? So second table set, we'll go at 250 pounds, and 250 centimeters would be the height, okay? And then I can go back to my table, and there you go, 128 kilograms. So being able to put that in there, putting that regression line in there, we can make some predictions on data as well, which is kind of neat. So just some basics on correlation coefficient. You're going to have to be able to calculate with your graphing calculator and be able to tell whether it's low or high or no correlation, either positive or negative. All right? Look forward to seeing you in class. If you have a different graphing calculator than me, we can figure it out together. Look forward to helping you. See you.